f of x maps to x squared plus 2x minus 4 is a function defined for all x values elements of the real number set. Part 1. By making a table of values, sketch a graph of y equals f of x for x values greater or equal to minus 5, less than or equal to 3. Part 2. Use the table of values to estimate the solution set of the inequality x squared plus 2x minus 4 is less than 0. Part 3. Use the graph and algebra to find the exact solution set of the inequality x squared plus 2x minus 4 is less than 0. So part 1, by making a table of values, sketch a graph of y equals f of x for x values greater or equal to minus 5 but less than or equal to 3. So our x values are going to be minus 5 up as far as 3, and we can either substitute these x values into our equation to get the corresponding y values individually, or we can use our f of x function on the calculator. Either way, we get these corresponding y values and we plot them on our x and y axis. So starting with minus 5, 11. So this is our x-axis. We go to minus 5, which is here. We go to 11, which is here, and we plot our first point. Next we have minus 4, 4. So we go to minus 4 on the x-axis, 4 on the y-axis, plot our next point. Then minus 3, minus 1, which is here. Then minus 2, minus 4, which is here. Then minus 1, minus 5, which is here. Then 0, minus 4, which is here. Then 1, minus 1, which is here. Then 2, 4, which is here. And then 3, 11, which is here. And then we join them together with a pencil, making sure that we have a curve at the base, not a pointed bottom to it. So it has to be a curve. Part 2. Use the tables of values to estimate the solution set of the inequality x squared plus 2x minus 4 is less than 0. So if x squared plus 2x minus 4 is less than 0, then y is less than 0. So from the table of values, y is negative from just less than minus 3 up to just more than 1. So we can see y is negative at minus 3. It's also negative at minus 2. It's also negative at minus 1, negative at 0, and negative at 1. So from here to here, we can see that our y values are negative, which means that they are less than 0. So from the table of values, our estimate of the solution set of y is less than 0 is approximately minus 3.3 and 1.3. So somewhere in between these two values, y is going to be less than 0. Part 3. Use the graph and algebra to find the exact solution set of the inequality x squared plus 2x minus 4 is less than 0. So by using the quadratic formula, x squared plus 2x minus 4 is equal to 0 when x is equal to minus 1 minus root 5 and when x is equal to minus 1 plus root 5. So the quadratic formula is also known as the minus b formula. Thus, by reference to the graph, the solution set of x squared plus 2x minus 4 is less than 0 is minus 1 minus root 5, which is going to be around here, and minus 1 plus root 5, which is going to be around here. So for you to put this into the calculator, you would get around minus 3.2 minus 3.3. And if you were to put this into the calculator, you'd get around 1.2, 1.3. If we are not required to make a table of values, then to solve an inequality such as x squared minus x is greater or equal to 6, we proceed as follows. Part 1. Bring all the terms to the left-hand side of the inequality. Part 2. Let y be the quadratic and construct a rough quadratic curve, noting the shape of the graph and where it cuts the x-axis. Part 3. Using the graph, write down the solution of the inequality. So for example, solve the inequality x squared minus x is greater or equal to 6 for x values elements of the real number set. So we're going to bring all the terms to the left-hand side. So x squared minus x greater or equal to 6 becomes x squared minus x minus 6, which is greater or equal to 0. We're going to let y be the quadratic. So we're going to let y equal x squared minus x minus 6. So we know that this is a U-shaped graph because we have x squared. If it was minus x squared, it would be an N-shaped graph. So then we're going to let y equal to 0, and we're going to factorize and we're going to solve. So x squared minus x minus 6 will factorize to give x minus 3 times x plus 2, which is equal to 0. So x minus 3 is equal to 0, so x is equal to 3. And x plus 2 is equal to 0, so x is equal to minus 2. So we can construct a rough graph. Here's our y-axis, here's our x-axis. We want to mark out minus 2 and 3 and draw a U-shaped graph that cuts through minus 2 and 3 on the x-axis. So if we take 0, which lies inside as our test value, we can check it in the inequality. So if we go back to our original equation, which was x squared minus x is greater or equal to 6, we're going to swap each of those x's for 0. So we have 0 squared minus 0 is greater or equal to 6. 0 squared is 0, minus 0 is still 0. So 0 is greater or equal to 6 is false. As this is false, 0 does not belong to the solution set. And remember, 0 lies inside of our values, minus 2 and 3. So this section of our graph contains the x value of 0, and we substituted the 0 into our equation, and we ended up getting a false statement because 0 is not greater or equal to 6. Therefore, the solution set must be outside, i.e. x is going to be less than or equal to minus 2, so all of this, or x is going to be greater or equal to 3, so all of this. So what we did was we took 0 as our test value, because we can clearly see in our graph 0 lies inside of minus 2 and 3. We substituted it into our original equation, and we end up getting a false statement. So 0 is not greater or equal to 6. So since it's false, it means this is not the solution set. Everything above it is the solution set. So everything that's less than minus 2 on the x-axis is going to be the solution set, and everything that's greater than 3 on the x-axis is going to be the solution set. Now, if we had substituted 0 in and we'd gotten a true statement, it would have meant that this part of the graph was the solution. So all these x values would have been our solution. So it would have been x values from minus 2 to 3. So it would have been x values greater or equal to minus 2 or less than or equal to 3. But it did not work out that way. We actually got a false statement. So it means everything that's outside of minus 2 and 3. So everything to the left of minus 2 on the x-axis and everything to the right of 3 on the x-axis. Quadratic inequalities can sometimes be used to determine the conditions under which a quadratic equation has real roots. So real roots, not imaginary roots. So no negative inside the square root. Recall that the roots of the quadratic equation, ax squared plus bx plus c is equal to 0, are given by the formula x is equal to minus b plus minus square root b squared minus 4ac all over 2a. So this is our quadratic formula, or a minus b formula. The roots will be real as long as b squared minus 4ac is not negative, i.e. b squared minus 4ac is greater or equal to 0. So we don't want to have a negative value underneath the square root, because then we'd have an imaginary number, also known as a complex number. So determine the values of k, which are an element of the real number set, for which the quadratic equation x squared minus kx plus 3k minus 8 is equal to 0 has real roots. So for the quadratic equation, or minus b formula, a is going to be 1 because that's really 1x squared. B is equal to minus k because there's a minus k stuck on in front of the x. And c is equal to 3k minus 8 because 3k minus 8 is technically our constant left over at the end because there's no x term attached to it. So we're just going to use this part of our formula, which is b squared minus 4ac, so everything under the square root. And we're going to let b squared minus 4ac be greater or equal to 0. Then we just substitute into our formula. We swap the b for minus k, so we get minus k squared. Make sure you've got brackets around it. Bring down the minus 4. We swap the a for 1, again with brackets around it. and swap the c for 3k minus 8, again with brackets around it, and this is all greater or equal to 0. Minus k squared is minus k by minus k, which is just positive k squared. Minus 4 times 1 times 3k is minus 12k. And minus 4 times 1 times minus 8 is plus 32, and this is greater or equal to 0. So now we have a quadratic in terms of k squared minus 12k plus 32 is greater or equal to 0. We're going to let y equal k squared minus 12k plus 32, and we're going to let y then be 0. So k squared minus 12k plus 32 is equal to 0. We're going to factorize. So we get k minus 4 times k minus 8. So k minus 4 is equal to 0, so k is 4. And k minus 8 is equal to 0, so k is 8. And if we draw out a rough graph, so here's our x-axis, here's our y-axis, we want to show that our quadratic curve crosses at 4 and 8. So there's 4, there's 8. We know we have a U-shaped graph because this is k squared, positive k squared, not negative k squared. So we have a U-shaped graph that crosses the x-axis at 4 and at 8. So again, we're going to take 0 as our test value. We can see that k equals 0 does satisfy k squared minus 8k plus 32 is greater or equal to 0. So what we'd end up having if we let k be 0 is 0 squared minus 8 times 0 plus 32, which would just give us 32, which is greater or equal to 0. So 32 greater or equal to 0 is true. As 0 is outside, the solution is outside. So we can see we have 4 and 8, and 0 is clearly outside of 4 and 8. It's not in between. So the values that are in between are 5, 6, and 7. So 0 is clearly outside, which means the solution is outside. So everything to the left of 4 on the x-axis is going to be our solution. And everything to the right of 8 on the x-axis is going to also be our solution. So thus the equation has real roots if k is less than or equal to 4, so less than or equal to 4, or k is greater or equal to 8, greater or equal to 8. So we subbed in 0 as our test value, and we got our statement to be true. And since 0 is outside of our solutions, which is 4 and 8, it's outside of that, then everything else that's outside belongs to our solution. If this had been false, however, it would tell us that our solution set lies inside 4 and 8. So it would be x values greater or equal to 4 and less than or equal to 8, so it would be the other way around.